Okay then, so now we're going to go on to another axiom, which is this axiom of extensionality. So I think this is probably the most complicated one, but we'll be fine because we have experience dealing with this stuff. So here goes. We have three variables f and g, and we want to show that this formula here implies f equals g. This formula here is for all x in A, e f comma x equals e g comma x, and we want to show that implies f equals g. Now clearly the converse is also true when f and g are the same, but anyway, a shorthand for this ef comma x is f of x, and a shorthand for this eg of x is g of x. But anyway, I won't use those shorthands very much because I like you being able to use round brackets to sort of delineate equations. So I prefer to actually say explicitly when I'm doing evaluation. Anyway, the question is, what is the interpretation of this term, this formula on the left-hand side? Well, it has three variables, f and g, in b to the power of a. And as usual, the interpretation is for all a, m transpose, where m is this arrow from b times a times b times a times a to omega, which is just basically the interpretation of this stuff. Now, because I'm writing it like this in this kind of double producted fashion, we have to sort of burrow in with iterative projections to get stuff out of this. For example, we might do P1 and then P2 to get the second b to the power of a. Anyway, the interpretation of this then, so we're talking about the interpretation of, so like the meaning of this is for all a transpose m, but what's m? Well, m is the interpretation of this, which is interpretation of ef comma x equals eg comma x over fg and x. And that's the interpretation, taking out this equal sign, it's interpretation of delta b of e of fx comma g of fx. And then like filling out the projections properly, that becomes delta b of e p1 times 1 comma e p2 times 1. And we see the expansions of these down here. So p1 times 1 is actually p1 comma p1 comma p1 p1 comma p2, and p2 times 1 is p2 p1 comma p2. Okay then, so let's suppose we have a generalized element of b times a times b times a, and then we ask ourselves, when is, so this generalized element, we call it f dash comma g dash, and we ask ourselves, when is f dash comma g dash in the extension of this? And that's going to happen precisely when doing this sort of interpretation of it for all a m transpose, doing that on f dash comma g dash gives true. Now, basically, we can use theorem 13.9 if we have r is equal to m star is equal to this this extension here. So this is the subobject classified by this. Okay. Well then, clearly M transpose is going to be chi-R transposed. And what they call in the theorem for all AR, and I'm calling it U, and it's here, this thing that this extension over the term we're most interested in, that's going to be the sub-object classified by for all A chi-R M, okay? And theorem 13.9 in this context tells us that we're going to have for all AR, or in other words, for all A M transpose, well, we're going to have F comma G is in for all AR using this terminology, if and only if, so in other words, F comma G is in this, which I'm saying is happening if and only if for all A M transpose of F dash comma G dash is true. According to theorem 13.9, that happens precisely when F dash comma G dash times 1 is in R, where R is M star, which is this extension over the sort of stuff here, just forgetting about this for orbit, just here. Okay. And this is basically the stuff we use for the M, okay? And that's going to happen, of course, if and only if that's wrong here. Right, so this happens if and only if doing M on F dash comma G dash times 1A gives true, or T after exclamation mark H times A. And that's going to happen, well, just expanding this out, we can rewrite this as F dash comma G dash P1 comma P2. That's a rewriting of this part. So this is going to happen if and only if M of F dash comma G dash P1 comma P2 gives true. Now we know what M is, we have it up here, so let's just substitute in, work out what this expression is. So we get TH times A equals delta B of EP1 times 1, EP2 times, comma, EP2 times 1, close brackets, operating on F dash comma G dash of P1 comma P2, and sort of expanding that, well, collapsing it down really, working out what it is. We can take this, hang on, I forgot my brackets right here. Yeah, we can take this inside the brackets like so. Hello? Yes, it is.